In this video, we are going to learn how to identify like terms. Now, why do we need to identify like terms? In order for us to simplify expressions, we need to be able to add the terms together where possible. However, we can only add like terms together. So what do we mean by like terms? For example, here I have two plates. On one plate I have 3 apples, and another plate I have 4 apples. And then I have another rug with 2 cats on it. Now, if I were to add all of this together, I'll be able to add the number of apples, 3 apples plus 4 apples. So I can say that I have 7 apples altogether. However, I can't add the number of cats to the number of apples. They are two completely different things. Therefore, I have to say that I have 7 apples and 2 cats. I won't be able to combine these two into 9, for example, because they are of different objects. Similarly, if I had 3x plus 4x plus 2y, 3x and 4x are telling me how many x I have. So on this box, I have 3 times of x. In this box, I have 4 times of x, which means altogether I have 7 times of x. However, y is a completely different term. I can't add these together with the x terms. Therefore, I'll only be able to simplify it to 7x plus 2y. Just like initially we had 7 apples and 2 cats. Now, let us look at what is the definition of like terms. You'll be able to see this table on page 6 of your notes. Like terms are terms where the variables match exactly, exponents included. Now, exponents means powers. So, when we say the terms are like terms, the variables must be exactly the same and the powers of the variables must be exactly the same. Now, let me give you a few examples before we go to the table. First, let me give an example. 3x and 7x. The variables are exactly the same. The power here is x power 1 and this is also x power 1. Of course, we don't usually write the power. So as long as they are the same variables and the same power, we consider them like terms. Another example, 3x squared and minus 7x squared. 3 times of x squared and negative 7 times of x squared. The variables are the same. And the power of the variables are also the same. Even though the coefficients, the 3 and the negative 7 are different, these two are considered like terms. Now, let me give a few non-examples. Three x and 7y. Just like in the example we saw just now, the variables are not the same, therefore they are not like terms. Next, 3x squared and 7x. Now, even though the variable is the same, we see x appearing in both the terms. However, in one of the terms, it's x squared. In the other term, what you see is x. The powers are not the same and therefore they are considered two different unlike terms. Therefore, these two terms cannot be added together. Let us look at one more example. Three xy and 7yx. Now, are these two the same? The first term has the variable x and y. The second term has the variable y and then x. However, we have discussed in class that 7 times y times x is the same as 7 times x times y. When we do multiplication, the order does not matter. Whether we take 2 times 3 or 3 times 2 gives us the same answer. Therefore, 7yx and 7xy are the same. Since they are the same, if we compare with this term, this is xy, this is also xy. So the variables are the same and the powers of the variables are the same. Therefore, these two are considered like terms. Now you can pause the video here to try completing this table before you take a look at the answer. What you need to do with this table is to identify whether the two terms given here are like terms or unlike terms. So you tick accordingly in the respective column. So you can pause the video here and try this first before continuing. Now let us take a look at whether these are like terms. 3a and 10a, the variables are the same and the powers are both 1. 3y and 10x, so it's like adding apples and cats, so unlike terms. 3 times of xy and 7 times of xy, so they are the same variables. 3xy and negative 7yx. So just now we talked about how the order does not matter in multiplication. So if I put it as 7xy, it would be the same. Therefore, these two are like terms. 3x squared and 7x. The powers are different. Therefore, they are unlike terms. A squared b and 2 times of a squared b. A squared is the same, b is the same. Therefore, these two are like terms. A squared b and a cube b. Even though the b is exactly the same and the a is the same, the powers are not the same and therefore they are unlike terms. Now this identifying of like terms and unlike terms is very important because we can only simplify expressions to combine the like terms. Only like terms can be combined into a single term. If there are unlike terms, there's no way we can simplify it. It's like 3 apples and 4 cats. There's no way we can combine it together. So now let us take a look at this table. We are going to try to combine the expressions which can be combined. So for the first example, 3a plus 10a, because they are like term, we can add them together. 3 times of a and 10 times of a. It's like asking if I have 3 apples and I have another 10 apples. So I will have 13 apples altogether. 3y plus 10x. There are no like terms, so there's no way we can simplify this, which means if this is your answer, this is the final answer, there's no other way to simplify this expression. Next, 3xy minus 7xy. So let's say xy represents dollars, money. Okay, so every xy is $1. So basically you have $3 and you need to pay someone $7. So in the end you would be owing them $4, right? So basically we take 3xy minus 7xy. So 3 minus 7xy. So it's negative 4xy. Now why is there still a xy? Why doesn't it disappear? Basically, when we are adding together or subtracting the terms, we are just asking how much is left after the subtraction, right? For example, if I had 10 apples and I took away 3 apples, I'll be left with 7 apples. There will still be apples left. It will be 7 apples. Okay, you won't just be left with the number 7. Okay, so similarly, here we'll be left with negative 4xy. Since the next expression is exactly the same, this will also be minus 4xy. Minus 4xy, sorry, not 7. This is negative 4xy. Okay, the next expression cannot be simplified because there are no like terms. Next, a squared b plus 2 times of a squared b. Now, if there's no coefficient in front, we have seen that it's actually a coefficient of 1. So I have 1 times of a squared b. I'm going to add another 2a squared b. So in the end, I'll be left with 3 times of a squared b. The last expression, there are no like terms, so there will be no way to simplify it. So the final answer will just be the expression given in the first column.